Hello students, welcome you to this session. In this class, we are going to study a special type of equations, that is system of homogeneous equations. You know what is homogeneous equation? Homogeneous equation means the degree same. If the degree is same, we call it as what? Homogeneous. Homogeneous system of linear equations. Only that type of equations we have to study. And this is the last topic in this chapter. So homogeneous means same degree. Degree must be same. Look at this example. Look at this equation. 2x minus 3y plus 7 is that equal to 0. Suppose x square is there, you know the degree is what? 2. But here 2x, degree is 1, right? For constant, what's the degree? 7, what's the degree? 7, the degree is 0 because it's a constant, no variables there, right? But what's the degree of 4? 0. What's the degree of 0? What's the degree of 0? Is it 0? Can be taken as 0. Can be taken as 1 because 0 can be written as 0 into x. Degree of 0 can be taken as 2 because 0 can be written as 0x square and so on. So, first term degree is 1. Second term is 3y minus 3y degree 1. 7y, 7z degree 1, right? Left side every term degree 1. Right side 0. 0 can be considered as degree 1 also because 0 can be written as 0 into 1. So, it is a homogeneous equation. Instead of 0, if we have some other number, suppose it is 6. It is not homogeneous because 6 cannot be written as 6x. But 0 can be written as 0x, right? Because 0 into x is 0 only. 6 into x and 6 are not same. So, this is homogeneous equation of degree 1. Because the degree is 1 for all the terms, 0 can be written as 0 into anything, x, 0 into y or anything you can write. So, it is homogeneous system. So, we are going to study equations of this type only today. And it is very easy to identify. When you see the equation x, y, z, right side, the constant values are all what? Zeros. Then you know it is homogeneous system of equation. It is always consistent. What's the meaning of consistent? Already we studied consistent, inconsistent. Consistent means solution exists. It has solution. They give 3 equations like this. The system has solution. So inconsistent case won't come. It is always consistent. How do you know? What is the meaning of solution? Solution exists. You give some value for x, y and z. It must satisfy, right? Can you guess some value for x, y, z so that the total must come 0? Don't think about very high numbers and all. Very simple number you put. For x you put 0, y you put 0 and z also you put 0. X you give 0, y you give 0, z also 0. So 0 minus 0 plus 0, the answer is what? 0. So right side is 0, so you give a number 0, 0, 0, it satisfies the equation, so that is a solution for any homogeneous equation of this type. So that is the reason we say it is always what? Consistent. So inconsistent case won't come here, it is always consistent. Then the standard form is, normally we write ax equal to b. B is the right side values. Here the right side values will be 0. So the standard form is ax equal to 0. The matrix equation is ax equal to 0. The method is, then usual method, you write the matrix equation, then augmented matrix A, B. Instead of B, you have what? 0. A, 0. Because the last column fully it is 0. Then reduce it to echelon form. If the ranks are equal, it is consistent. Ranks are not equal, inconsistent. But it won't come here. It is always consistent. But only thing, it has unique solution or infinitely many solution. When the ranks are equal to number of unknowns, it is consistent unique solution, right? Unique solution means, can you tell me what is that solution? Already we saw that. By seeing itself, you can say no need for any calculation. If there is only one solution, it must be x equal to 0, y equal to 0 and z equal to 0. And that solution has a special name. We call it as trivial solution. What's the name of that? Trivial solution. Trivial solution means x equal to 0, y equal to 0, z equal to 0. So in the case of unique solution, the solution itself, it is 0, 0, 0. No need for any calculation here. And the other case, when the ranks are equal but less than number of unknown only, we say infinite number of solutions. Okay. So standard form is ax equal to 0. The solution x equals 0, y equals 0, z equals 0 has a special name. What's the name of that solution? It is called what? Trivial solution. Then What is the meaning of infinite number of solution? The 0, 0, 0, that is called trivial solution. All other solutions are called non-trivial solutions. 0, 0, 0, that one particular solution is called what? Trivial solution. All other solution, if it has many solutions, except that solution, all other solutions we call it as what? Non-trivial solution. So trivial solution only one. What is that? 0, 0, 0. That is called trivial solution. Any other solutions, if we have that solutions are called non-trivial solution. Together we call it as infinitely many solutions. So infinitely many solutions means it is a union of trivial solution and what? Non-trivial solution. Trivial, non-trivial, together we call it as what? Infinitely many solution. So please remember one important point I want to tell you. Infinitely many solution and non-trivial solution, they are not same. Infinitely many solution and non-trivial solution, they are not same. What's the difference? Non-trivial solution means it has all the solutions, but one won't be there. Which won't be there? 0, 0, 0 won't be there, because that is called trivial solution. Except that solution, all other solutions are called what? Non-trivial solution. But infinitely many solution means not only the non-trivial solutions, trivial solution also you have to include. Okay, that is called. So one solution extra, that's all. Okay, so infinitely many solution is the union of trivial and non-trivial. Together we call it as infinitely many solution. Don't forget this important thing, the difference between non-trivial and the infinitely many solution. Non-trivial 0, 0, 0 won't come there. Infinitely many solution, that also an extra point. Okay. Now the condition, very simple thing. You find augmented matrix A 0 normally here. Okay, B, but here B is 0. Right side values are zeros, right? So rank of AB and rank of A are equal and equal to number of unknown. Don't think every time it should be 3, 3. Not like that. It can be 4 also. So we have a sum in 4 variables also. Okay. So number of unknowns, like that you study. Rank of AB, rank of A both are equal. Equal to number of unknown, then you know the system is consistent. In this case, every time it's consistent only. Unique solution, because equal to number of unknowns, unique solution. And in the case of homogeneous equation, to find that unique solution, no need to do any calculation. What is that unique solution? It is trivial solution. What is the trivial solution? X equal to 0, Y equal to 0, and Z equal to 0. Okay, that is when the ranks are equal to number of unknown, this is the solution. No need for any calculation. When the ranks are equal but less than number of unknowns. Ranks are equal but less than number of unknowns. Suppose the number of unknowns are 3, X, Y, Z. It is 2, 2 or 1, 1. Already you studied that type, right? Then it is consistent. It has infinitely many solutions. Whether the system reduced to one equation or two equation depends on the rank, whether it is 2, 2 or 1, 1. Okay, so it has infinitely many solutions. Okay, that's all the theory part for this exercise. We'll try a few questions. Look at the first question. Solve the following system of homogeneous equation. Homogeneous equations, even if it is not specified, you can identify. How can you identify? X, Y, Z. Right side, the constants must be zeros. Okay. So first equation, 3x plus 2y plus 7z equal to 0. Right side is 0. Again right side 0. Again the right side 0. You may ask, sir, 2 of the values 0, 1 is not 0. It is not homogeneous system. The whole system is homogeneous, means for all the 3, the degrees must be same. Okay. In 2 cases, the right side is 0, 1 is not 0, means it is not homogeneous. You have to do it the previous method. Okay. So here the right side values are zeros. So it is homogeneous system. You know it is always consistent. You know the matrix equation. So all the steps may not be right here. You have to write the steps. Matrix equation, you know how to write. Coefficient matrix, column matrix, the unknowns. What are the unknowns? X, Y, Z equal to 0, 0, 0. So then you will get Ax equal to 0. Then I am starting with augmented matrix. After that you will be writing augmented matrix. Instead of AB, you write A0. A is the coefficients. 3, 2, 7, 4, minus 3, minus 2, 5, 9, 23. Attach B values. Here B is 0. 0, 0, 0. Reduce it into echelon form. How can you reduce to echelon form? Hope you practice a lot of questions. You may be thorough with that now. There are different methods, right? First row, first element, we have to get 1. But in that column you see no ones here, right? Otherwise you would have interchanged. You make some 1, either 4 minus 3. 4 minus 3 is 1, then you can interchange. Or 5 minus 4 is 1, then you can interchange. Any method you can use. So what I am doing here, subtracting these two, 4 minus 3. So what step you write? R2 is R2 minus R1. R2 is R2 minus R1. So 4 minus 3. Minus 3, minus 2, minus 5, right? So you will be getting this step. R2 is R2. So you are getting 1 here. Now that one we want to the first row. So what do you do? Interchanging first row and second row. Interchanging first row and second row. So this goes up. Now we want to make these two numbers zeros. How can you make 0? 3 minus 3. So R2 is R2 minus 3R1. This we want to make 0. 5 minus 5. So R3 is R3 minus 5R1. Okay. So R3 is R3 minus 5R1. You will get this step. Now look at this. First row, first element 1, below that 0. Second row, second element 1, if possible you try to get. If not, you make this as 0 definitely. But here you can see 17 table you can cancel. 17 2s are what? 34. Here 34 is common. 34 table you can divide it. So you divide the second row by 17, third row by 34. Okay, you can understand steps. You are getting like this. First row, first element 1, below that 0. Second row, second element 1. We want to make this a 0, very simple, 1 minus 1. So R3 is R3 minus R2. R3 is R3 minus R2. So you are getting like this. Now see the last row fully 0. Now from here you can find both the ranks. You can find rank of AB. How many non-zero rows? Only 2. What is rank of A? Leave the last column, right? Leave the last column. See how many non-zero rows? That also 2. Rank of AB is 2. Rank of A is also 2. So what you can say? Ranks are equal. So it is consistent. Already you know homogeneous system is always consistent. But less than number of unknowns. Here number of unknowns are 3, X, Y, Z. But the ranks you are getting 2. So it is consistent. It has infinitely many solutions. Now what you do? Again you write into matrix equation, right? You take the first 3 into X, Y, Z equals 0, 0, 0. You will get the corresponding equations. Can you tell me the equations? X, Y, Z equal to. So what's the first equation? X minus 5Y plus 9Z equal to 0. Again, X, that is 1X, minus 5Y minus 9Z equal to 0. Second one, 0X, leave it. Y plus 2Z equal to 0. That's all. Last one fully it is what? 0. Okay. So that's what you are getting here. Echelon form. Ranks are equal. Less the number of unknowns. So consistent, infinitely many solution. Equivalent equations are, you are getting only 2 equations. With 2 equations you cannot solve it, right? So what we do? Already you studied. Put Z equal to T. Put Z equal to T. Second equation you substitute. Put Z equal to T. So 2T. Take that 2t to the right side, so y equal to minus 2t. You will get y equal to minus 2t. Now y value and z value, you know, substitute the first equation, take it to the right side, you will get x value also. And this is your x value minus t. Finally, write the answer, x equal to minus t. Y value you are getting, right, y value got it, minus 2t and z equal to t. And don't forget to say t belongs to R. T belongs to R. It is set of real numbers. When you give different values, you will get different set of answers. So that is why we say the system has infinitely many solutions, right? It's a very simple thing. Homogeneous system, right set values are zeros. Always consistent. So in this case, consistent, infinitely many solutions. Shall we go for the next question? Look at this. First equation, right side 0. Second equation, right side 0. Third equation also right side 0. The left side x, y, z. Sometimes the constant they give here equal to 0. That is not homogeneous. Constant take it to the right side. Left side x, y, z. Constant to be in the right side. And then you see whether the constants are what? Zeros. The right side values are zeros. It is homogeneous. It is homogeneous system. Matrix equation you can write Ax equal to b. Then you can write the augmented matrix A0, right? Augmented matrix A0. So coefficients you write, then 0, 0, 0. Coefficients while writing, you have to be very careful. If it is minus, you write that. If a term is missing, you put 0. Sometimes read the question very carefully. Sometimes x, then z they may give, then y. you have to read the question very carefully and write. Okay. So this is augmented matrix. Reduce it into echelon form. First row, first element, we want to get 1. It's very simple. Here we have 1, right? Interchange first row and second row. Interchanging first row, second row, you are getting like this. Now we want to make these two zeros. How can you make this 0? 2 minus 2. R2 is R2 minus 2R1. 3 minus 3. R3 is R3 minus 3R1, right? So when you do that, you are getting this equation. Then listen, then the next one is very simple. Second row, second element 1. I want to make this 1 here. First row, first element 1, below that 0. Second row, second element 1. Try to make it as 1. If you're not able to make, at least this you make it as 0. Okay. But here you can make it as 1 very easily. 5 minus 4. 5 minus 4. So what step you write? R2 is R2 minus R3. R2 is R2 minus R3. R2 is R2 minus R3. So 5 minus 4. It is 1. 3 minus 9 minus 6, 0 minus 0, 0. Third row, no change. So first row, first element 1, below that 0. Second row, second element 1. We want to make this as 0. How can you make this 0? 4 minus 4. So R3 is R3 minus 4R2. R3 is R3 minus 4R2. Practice well these calculations. Okay. Now this one, if you want, you can make it as 1 or even leave it, no problem. If you want, make it as 1, dividing by what? 33. Then, or you can leave it. It is in echelon form. What is rank of AB? You see the whole thing. Rank of AB, 1, 2, 3. Rank of AB is 3. What is rank of A? Leave the last column. How many non-zero rows? 3. So, rank of AB is 3. Rank of A also 3. Ranks are equal and equal to number of unknowns. So, what can you say? System is consistent. Which type consistency? Unique solution. If it is unique solution in this type questions, you no need to solve. What do you do? Because it is homogeneous system, if the solution is unique, you know the trivial solution. What is trivial solution? X equals 0, Y equals 0, Z equals 0, and you can stop here. Okay. It is in echelon form. Rank of AB or A0 equal to rank of A equal to 3 equal to number of unknowns. The given system consistent, always consistent. Unique solution, that is trivial solution, and x equals 0, y equals 0, and z equal to 0. It's very easy, no need to calculate anything directly, you can write. Okay, now we go for another question. Determine the value of lambda. Determine the value of lambda for which the following system of equations. First equation, the right side value is 0. Second equation, with there is an unknown, lambda is there, right side value is 0. Third equation, correct form, the right side value is 0. So, homogeneous system. They didn't specify anything, but you know the right side values are all 0, so it is homogeneous. What value should be given for the system to have unique solution? So, homogeneous system, unique solution means it is what? Trivial solution. So, x equals 0, y equals 0, z equals 0. When you will get to unique solution, rank of AB equal to rank of A equal to 3 in this case, because there are 3 unknowns, right? That is the first case, unique solution. But already you know, unique solution and trivial solution both are same. Unique solution and trivial solution are same. But infinitely many solution and non-trivial solution, they are not same. Because infinitely many solution means it includes trivial and non-trivial. Together only we call it as what? Infinitely many solution. But here they didn't ask infinitely many solution. What value should be given to lambda so that the system has non-trivial solution? Non-trivial solution means you should not get that 0, 0, 0. Other than 0, 0, 0, all other solutions. Okay. Let us see usual method. When you come to the last step, I'll tell you one more time, I'll explain. Correct form, matrix equation we write, then you write augmented matrix A0, right? Ax equals 0, this is a matrix equation. For every sum you have to write this step, okay? Ax equals 0, A means the coefficients, 1, 1, 3, 4, 3, lambda, 2, 1, 2. A, x means unknowns, x, y, z. If it is ABC, you write ABC. Sometimes they give you x1, x2, x3, you write x1, x2, x3. Then right side value 0, 0, 0. Then you write augmented matrix, with this attach this also. How can you reduce into echelon form? Very simple. Already first row, first element is 1, right? We want to make it as 0. How can you make 0? 4 minus 4. So second row minus 4 times first row. This you want to make 0. 2 minus 2. So third row minus 2R1, right? R3 is R3 minus 2R1. So both the terms will become what? 0. So you are getting this term. So first row, first element 1, below that 0. Second row, second element 1, okay, minus 1 is okay. If you want, you can change the sign. And you can make this as 0. This minus this, if you subtract these two, you will make this as what? 0. Okay, so what we do? R3 is R3 minus R2. So minus 1 minus plus, so it is 0. When you subtract, you have to be very careful. Second one, you change the sign. Minus 4 minus of this. So minus 4 minus lambda plus 12. Minus 4 plus 12, it is 8. So 8 minus lambda. If you want, you write and see. Okay, you will get this term. You cannot simplify further. Already you did few sums like this in the previous class, right? First row, first element 1, below that 0. Second row, second element 1 are non-zero number, okay? Below that it is 0. It's important. Now, everything depends on lambda value. What is the rank of AB? Simply you cannot say 1, 2, 3. Because you don't know the value of lambda, right? If lambda value 8, the whole thing will be 0. If lambda is any value other than 8, you will get a number here, right? So there are two cases. First, let us see unique solution, right? Unique solution. Unique solution means rank must be 3. Rank must be 3 means here already 1. Here also some element is there. So rank 2. To make rank 3, these 3 already 0. You cannot make any change. This 0 is 0 only. You cannot make it. Only thing you can do something here by changing the value of what? Lambda. So only this you have to see now. I want the rank as 3. So I want a number here. If I want a non-negative number, you give any value other than what? 8. So lambda can be given any value other than what? 8. So for unique solution, you put lambda not equal to 8. So meaning you don't need to mention which number you are going to give. Okay, only thing you give any value other than 8, you will have a number here. When you have a number here, rank will be 3, right? So rank of A, B and rank of A, both 3 equal to number of unknown. So the system has unique solution. Since it is homogeneous, trivial solution and it is x equals 0, y equals 0 and z equal to 0. Okay, that is for the first part. Only thing they asked what value should be given for lambda to get unique solution. But in the case of unique solution and trivial solution, both are same in this case. Okay, homogeneous system, this is the solution. Second case, they didn't ask infinitely many solution, they asked non-trivial solution. So a small difference only I already told you, so I will tell you again that part. To get infinitely many solution, you know ranks must be equal but must be less than number of unknowns. So rank cannot be 3. Rank, we don't want rank 3 means you make this as 0. How can you make this 0? Put lambda is equal to 8. If you put lambda here, lambda not equal to 8, right? If you put lambda equal to 8, 8 minus 8 is what? 0. This row fully 0. Here also there is a lambda, no? So lambda value 8 we are giving, right? So 8 minus 12, this become minus 4. No change in other portions at all. This becomes 0 and this become minus 4 because we are giving lambda is equal to 8. So when you give lambda is equal to 8, you are getting like this. That minus 4 and this become what? 0. Now you know the rank of AB is 2. Because it's fully 0. Rank of A is also 2. Both are equal but less the number of unknowns. So the system is consistent but it has how many solutions? Infinitely many solutions. So you can write the corresponding equation. Can you tell me what is the first equation? X plus Y plus 3z equal to 0. Second one, 0x, leave it. Minus Y, because minus 1y, minus y, minus 4z equal to 0. That's all right. You are getting only 2 equations. But 3 unknowns. What's the method? You know, put z equal to t, right? You put z equal to t and you can find y value. Put z equal to t, you are getting y value. And that y value and z value, you substitute in the first equation. From that you can find x also. Simple calculation, you can do that. But now listen here. X equal to t, y equal to minus 4t, z equal to t. Normally for these type of questions, when t comes, we give the range of t also, right? T belongs to R, we write. R means any real number. When you give any real number, you get a solution. But since it is non-trivial solution, they asked, you cannot give 0. T equals 0 if you give, suppose, because R means it includes 0 also, right? So if you put 0, what is X value? 0. What is Y value? T you are giving 0. Minus 4 into 0, 0. And what is Z value? That also 0. So what is your solution? X equals 0, Y equals 0, Z equals 0. That is not non-trivial solution, that is trivial solution. But if they ask infinitely many solution, that can be. So you can say T belongs to R. But here, T can take any real number other than 0. Because if T takes 0, the solution becomes 0, 0, 0, and that is trivial solution. They specified non-trivial solution. Okay, so the final answer is X equal to T, Y equal to minus 4T, Z equal to T, where T belongs to. Very careful in this one. These type questions, you mark it. Even the public exam time, the students make mistake here. Because in all the sums, we write T belongs to R. Okay, but for this particular question, you have to write T belongs to R minus 0. T cannot take 0. Because if it takes 0, the solution become trivial solution. Here they specified non-trivial. But instead of non-trivial, if the question is infinitely many solution, you can take 0. In that case, T belongs to R. Okay, it's a very important question. Practice well and you mark it. Okay. Now we go for another question. By using Gaussian elimination method, the same method only, balance the chemical reaction equation. Okay, listen here. So normally in physics, chemistry, maths will come, but in maths, chemistry is there. Okay. So using Gaussian elimination method, balance the chemical reaction given. Okay, you know this, right? In chemistry, you would have done so many questions. But I am going to teach one method. This method is a 5-mark question, right? Don't try this method for your chemistry questions. Okay. This is only for this purpose only. Okay, listen. So balancing, here the front you write some number, right? Here one number, here one number, here one number. Sometimes it may be 1 also, right? So how many numbers we need? 1, 2, 3, 4. So 4 unknowns. We name them as x1, x1, x2, x3, x4. We find that x1, x2, x3, x4 and substitute, right? So balancing here carbon home 2, but here 1, right? We won't make it so some number we write in the front, okay? Like that for all other atoms. See the solution. Here we attach one x1, here x2, here x3, here x4. So this is your final answer. But we want the values of x1, x2, x3, x4. Find all the values, substitute, and that will be the final answer. Okay. So for that, what do you do? We frame how many equations? So here carbon, hydrogen, oxygen. 3 equations only you get. You will get 3 equations, but 4 unknowns. So definitely we'll give some substitution, right? Okay. First, we equate carbon. Carbon, see how many here 2. Coefficient is x1. So total are 2x1, right? 2x1. Here no carbon. So equal to 2x1 equal to, here no carbon. Here we have, right? Carbon. Here 1, but before that x4. So x4. 2x1 equal to x4. 2x1 equal to x4. Bring it to the left side. 2x1 minus x4 equal to 0, first equation. So many times missing, you put 0 later, okay. 2x1 minus x4, 0, that is for carbon. Next for hydrogen. See the coefficients, here 6 atoms, outside x1. So 6x1, right? Hydrogen we take, 6x1, here H is not there, here H is there. So 2x3. So what is that again you see? 6x1 equal to 2x3. 6x1 is equal to 2x3. 2 you can divide, 2 is common. Then bring it to the left side. So when you divide by 2, 3x1 equal to x3. Bring it to the left side. 3x1 minus x3, 0, second equation. So first carbon, hydrogen, now oxygen. Left side, here there is no oxygen, here 2x2, right? 2x2 is equal to, here oxygen, both 2 terms. So 1x3 plus 2x4. Tell me again. Extend, you see, 2x2 is equal to 1x3, that is x3, plus 2x4. You cannot cancel anything here. Bring everything to one side. Arrange it. 2x2 minus x3 minus 2x4 equal to 0. So 3 equations. Now usual method. But remember number of unknowns, 4 here, right? x1, x2, x3, x4. After finding all the values, you substitute here. But x1, x2, x3, x4 must be whole numbers, cannot be fractions. If it is fraction, we make some LCM, we multiply and we write the values here, okay? So now usual method, instead of x, y, z, we have x1, x2, x3 and x4. So matrix equation you can write, but so many times missing, minus is there, so put zeros and all. What are the coefficients you see? For the first one, what's the coefficient? 2, 0, 0, minus 1, because x2, x3 missing. So when you write the equation, 2, 0, 0, minus 1, 2, 0, 0, minus 1. Second one, x1 is there, x3 is there, x2, x4 missing. So what are the coefficients? 3, 0, minus 1, 0. Like that from here also you can write. The right side values are all what? Zeros, right? Here the unknowns are x1, x2, x3, x4. There are 4 unknowns. Then you can write augmented matrix. This is your augmented matrix. Reduce it into echelon form. We want 1 here, right? So 3 minus 2. R2 is R2 minus R1. R2 is R2 minus R1. So 3 minus 2. So you will get 1. Interchanging first row, second row. You get this step. So 1, we want to make these two 0. Already this is 0. We want to make this 0. 2 minus 2. So R2 is R2 minus 2 R1. So you will get this step. Now, first element 1, below that 0, second row, second element 1. Interchange these two, that's all. Interchanging R2 and R3. Interchanging R2, R3. Either you make it as 1 or you can leave like this, no problem. Now listen, it is in echelon form. What is the rank of AB? If you want, you can make it as 1. Divide. Fractions to avoid, you can leave it. Okay. It is in echelon form. Rank of AB is 3. Rank of A, you see, that is also 3. Rank of AB equal to 3. Rank of A equal to 3. Ranks are equal 3, 3. So what's your conclusion? Consistent unique solution or infinitely many solution? So far for 3, 3 we have written in unique solution because 3 unknowns, x, y, z. But here how many unknowns? 4 unknowns. So ranks are equal 3, 3. But number of unknowns 4. So you have to say rank of AB equal to rank of A equal to 3 but less than number of unknowns, because in this case number of unknowns 4. So it is consistent, but it has how many solutions? Infinitely many solutions. So you can balance this equation infinite number of ways. That's the meaning. Write the corresponding equations. What's the first one? x1, x2 is not there, minus x3 plus x4 equal to 0. Again, x1 minus x3 plus x4 equals 0. Second one, 0x1, leave it. 2x2 minus 1x3 minus 2x4 equals 0. And the last one, x1, x2 is not there. 2x3 minus 3x4 equal to 0. Minus 3x4 equal to 0. There are 3 equations, but how many unknowns? 4 unknowns. So the fourth one you put t. We take x4 as t. We substitute x4 equal to t. When you put x4 value t, you will get x3. Calculation part you have to do. For x4, you give t. So 3t, take there plus 3t by 2. So x3 you will get. That x3 and x4 you substitute, you will get x2. That x3 and x4 you substitute, you will get x1. You will get x1, x2, x3, x4, everything in terms of t. Everything you are getting in terms of t. But in t, you can see all fractions, right? Sorry, the values are in fraction. x1, t by 2. x2, 7t by 4. x3, 3t by 2. x4, you put t, right? So maximum you can see 4 is there, no? So multiply everything by 4. Or you can put t equal to 4. Put t equal to 4. So x4 value t, 4. Here you multiply by 4. 2 and 4 cancel, so 2 into 3, 6 you will get. Here you put 4, 4 cancel, you will get 7. Here you put 4 by 2, 4 by 2 is 2. So x1 value you will get what? 2. Here 4 cancel, 7. So when you put These are the values you are getting. x1, x2, x3, x4. Don't stop there. These values you substitute in the first equation. You are remembering the given equation we attached x1, x2, x3, x4, right? These values you substitute. So instead of x1 you give 2. So 2, here 7, here 6, here 4. Are you able to understand this? But this method only for mathematics for this question. Don't use it for your chemistry sums. Okay. Okay, that's all. We finished all this. Now it is your work. You have to prepare well. Prepare well. Get ready for the test. You may ask how we are going to conduct test. You are going to write online test. We are going to conduct online objective test and unit test number 1. See you in the next class.